far away, at 79 degrees north latitude, almost to the North Pole, lies an Arctic archipelago called Svalbard. On its largest island, Spitsbergen, along the beautiful Kongsfjorden, is a science research station at Nilesund. Here at the Kings Bay Marine Laboratorium, students from the United States are conducting oceanographic research into the water in the fjord. Working from small boats right next to Kronbreen Glacier, they measure properties of the water and how it is changing. Ryan Paella from the University of Massachusetts is working with an instrument known as a CTD to measure properties of the ocean water. The first step is to become familiar with the instrument. CTD stands for conductivity, temperature, and depth. As the instrument is lowered into the water, it continuously takes those measurements. Conductivity is a proxy measurement for salinity or saltiness. The more salt that there is in the water, the better the water will conduct an electric current. Once the measurements are made, Ryan downloads the data to his computer and sets up the software to read his data. With that all set up and ready to go, it's showtime. We head out to the front of the glacier and take the first of 6 CTD casts. Down it goes. And with help, Ryan winches the CTD back up. Later he will return to the lab and download the data. This is a display of the data from one of Ryan's casts. Let's take a look at it. On the y-axis is depth in meters. The CTD took measurements to the bottom at about 35 meters. On the x-axis, we've got temperature in degrees Celsius in red and salinity in practical salinity units, which are equivalent to parts per thousand, in blue. This CTD also measures OBS, or optical backscattering. This is how much light reflects back from the water and is a reflection of the amount of sediment in the water column. That is the green line. All of these lines come in pairs because the CTD measures as it goes down and as it comes up. Looking at this data, we can ask some interesting questions. First, what do you think is causing the water to be colder at the surface than it is at depth? The water also has a greater salinity at depth. Could both of these trends be caused by the same phenomenon? Take a look at the green line. Much more light was scattered at the surface than at depth. So where is most of the sediment? What factors could be contributing to this? These are the types of questions asked by oceanographers and glaciologists. Thanks, Ryan, for sharing your data with us, and good luck!